I think Professor Naz Onel, your time to alert you. David, be with us and looking forward also to see you tomorrow.
Thank you, Dr. Hanadi, and thank you, David. This was a great session, and you're only 2 minutes over time, and this is impressive, actually, considering all the different sessions and so many people are attending. Hanadi, as always, you're doing an excellent job. It's so impressive how this is going so smoothly, and congratulations. It's another great conference.
Much. Thank you for your support. We miss Mike this evening. He is in the flight going to the daughter.
It's 2 p.m. here. I'm in New Jersey, so but I've been enjoying it. Thank you again for having me. When I have been asked if I could join again, I attended last year's sessions, and it was a pleasure. I learned a lot, and when I was asked this year, I was ecstatic. I said, yes, I want to be there. So thank you again for having me. So
thank you. More than welcome all the time.
Thank you. So this session 7, innovative approaches to teaching entrepreneurship and creativity. This is the session we will have 3 presenters, and I saw them. They are already here, which is wonderful. First, I want to again thank you, Professor Hanadi, for having me this year again. And last year, I found attending this conference really, really very eye-opening, enriching experience, and thank you for leading this amazing conference. From all over the world, the attendees, we get to see each other, listen to each other, and get connected through social media and other sources. Thanks for leading this. Thank you again. A little bit about me, just really briefly. I'm an associate professor of business administration and director of the dual degree program at Stockton University, which is in South Jersey, New Jersey, in the US. As I said, it's 2 p.m. here. It's a good time. It's sunny, although it's a little cold here, but it's a nice day. I teach graduate and undergraduate courses. I do a lot of research on consumer decision-making and well-being, artificial intelligence and sustainability marketing, digital consumer behavior, consumer environmental and social behavior, and corporate social responsibility. So these are some of the areas that I'm focusing on. So this conference is really also, in terms of the research area that I'm interested in, so much richness it's bringing to me and my research, and that's why it's a pleasure to be here. First, we will start with Dr.wassim al-balkhy from Central Lille Institute. I think I barely, yes, I'm seeing him. He's right here with a very pretty view in the background.
Thank you.
Is that where you are? Is it Paris?
Yeah, we are in Lille. It's 1 hour away from Paris by high speed train.
I do not have the title of your presentation, but the floor is yours.
Okay.
Everybody's going to get 15 minutes, and we will get the questions at the end, if that's okay with you. So the floor is yours. Thank you for joining us.
Okay, thank you, Naz. Thank you, Hanadi, for this opportunity to invite us. My presentation. Can you see my screen?
Yes.
So my presentation is entitled Lean Construction 4.0, Human and Technology for Value and Continuous Improvement. Firstly, I would like to introduce myself. I am a postdoc researcher in Central Lille Institute, which is a school of engineering in the city of Lille in the north of France. I got my PhD in civil engineering recently, working on the topic that I'm presenting it today. I have a master's degree in engineering project management from University of Jordan, and I am a member of the board of directors of the French Lean Construction Institute. And I have 13 years of experience in the construction industry, in addition to other things that can be mentioned later. So the plan of this presentation will include a general context for the construction industry, then covering the topic of my presentation, which is Lean Construction 4.0, then some few examples very quickly about the integration between the two sides of this concept, and finally covering the future of this topic. So the construction industry, as it is widely conceived, it's one of the most important industries in the world that employs more than 97 million people around the world, and it has more than $13 trillion spending every year. However, this industry is suffering from different problems related to the low productivity levels, the large amount of wasted time, the large amount of non-value adding activities, or what it means, the activities that are done for nothing, in addition to the vast amount of waste in this industry. So taking an example, the French construction industry, it's not an exceptional industry. It has the same problem that every construction sector in the world suffer from. For example, in 2019, there was more than 28 company deaths in the country in the field of construction industry. There are one accident every 2 minutes in the industry in France. More than 45% of the home buyers are not satisfied with the quality, and more than 25% of them are not satisfied with the delivery of time. And there are large amounts of construction and demolition wastes. Out of them, many of them are hazardous wastes. And in addition to that, there is a very low level of spending on research and development in the construction sector in France. This is the general case in the world, and it's also in France. So therefore, there is a need to create a change in the industry, the need to create a change in the practices, in technology, and in the way of thinking. One interesting report was presented by McKinsey & Company, showed different opportunities to create this change in the industry in terms of reshaping the regulation, reviewing the way of contracting, rethinking about the design, improving the whole supply chain and procurement practices, and reskilling of the workers. And the same report pointed out to the importance of the industrialization of this industry, of the construction industry, by presenting some technology-based solutions. The construction industry is known as a low-tech industry that does not value a lot the importance of technology. In addition to creating some different practices, depending more on modularity, prefabrication, and standardization, and the adoption of lean construction. So the adoption of lean construction with construction 4.0 can be covered when working on the title of Lean Construction 4.0, which is the integration of two important concepts, lean construction and construction 4.0. So starting with the first concept, the origin of lean construction comes from Toyota production system, which were developed to efficiently and quickly deliver high quality vehicles to satisfy the client needs. So based on the lean thinking, everything that does not add value for the client, it's a waste and should be eliminated. And there is a need always to create a continuous and smooth flow of work, materials, and information in order to make a continuous improvement in the production process. So apart from the different definitions of lean construction, there's one interesting definition that we can adopt. In the project management thinking, there is this ironic triangle, or the project management triangle, which suppose that there are, for each product, project, or service, there are three main constraints: time, quality, and cost. And whenever we want to improve one of them, we are obliged to sacrifice at least one of the others. So if you want to deliver the project earlier, we may sacrifice the quality and cost. But lean thinking is about working in order to try to improve everything together: time, cost, quality, and even go beyond that to improve stakeholders' engagement, collaboration, safety and health, sustainability, and client satisfaction. The other concept is the Construction 4.0, which is about the application of the fourth industrial revolution technologies and practices in the company, in the project or in the production process. In these systems, Industry 4.0 enables all actors to interact and communicate with each other using innovative technologies and practices. And in these systems, organizations, devices, and processes communicate and exchange information autonomously and continuously to enable information-based decision-making process. There are many Construction 4.0 or Industry 4.0 that applications and technologies that can be applied to the construction industry, such as 3D printing, digital fabrication, building information modeling, digital twin, artificial intelligence, Internet of Things, and many others. So the motivation to work on this topic comes from the shared objectives between the two concepts, lean construction and Construction 4.0, which are about improving the innovation, sustainability, cost and time saving, safety condition, quality, predictability, and many others. In addition to the need to integrate these two concepts, one example is lean construction is sometimes considered as a low-tech concept, while Construction 4.0 it's a very high-tech solution. So when we talk about their integration, that means that we don't overemphasize on the technology and neglect people, and at the same time, we benefit from the advanced technologies in order to improve the information sharing, the reduction of complexity, the inclusion of the client, and the traceability of the client's needs and requirements. So the first example in this presentation about the integration of lean construction and 3D printing. So their integration, while lean construction very helpful to identify the value and work for a better value and improving the process continuously, 3D printing is helpful to improve safer, greener, and better construction environment. So both of them can work together. So examples of how 3D printing can eliminate waste. 3D printing can eliminate, in comparison to conventional construction methods, 3D printing can eliminate waiting for materials, for transportation, for formwork, or for resources. It can also reduce the large amount of waste in inventories, the transportation of workers, machines, and materials, in addition to the overproduction of material. In turn, 3D printing themselves may have some waste that should be eliminated, such as the defective layer, the design error, unprintable materials, waiting due to maintenance or quality measurements, transportation of spare parts, and overproduction also. The other example is about the integration of lean construction and Internet of Things. And this is one of the results of our research. It is what we call lean construction and IoT matrix. It's based on the integration of lean construction principles, which are flow, creating a smooth and continuous flow, value generation, problem solving, and developing partners. In addition to the IoT functionalities, which are about monitoring, control, autonomy, data transfer, data storage, data analytics, and integration. And such integration is helpful to create a quicker decision-making process to ensure the work continuity on site in the construction site, to maintain the inventory levels, to include the requirements and to trace the requirements of the client, and to solve problems even before they happen, so due to early warnings, and to benefit from real-time information and data to improve connectivity between different partners in the construction project. The third example is about the integration of lean construction and digital twin. So digital twin is about creating connection between the digital asset, the physical asset and the digital replica of this physical asset, and then improving the decision-making based on the quality of the data collected from the physical assets and managed and analyzed in the digital replica. So this integration is helpful to improve planning and visualization in terms of visualization, understanding the process and continuously visualize this process, and provide the opportunity for different partners to have access to these plans and achieve the principles of collaborative planning for lean construction. It also helped to improve the monitoring and control process using the real-time data and identifying the bottlenecks and eliminate the waste in the process. This integration is also helpful in order to risk mitigation or risk management by doing some simulation in the digital twin and application of the error-proofing principles of the lean construction. And finally, improving the supply chain management by modeling of the entire supply chain to optimize the production and delivery, and achieving zero inventory and avoiding waste in the inventory. So the future of lean construction 4.0, very quickly, there are many opportunities to work on this topic, including, firstly, providing some ways to identify the maturity levels of the application of this concept or this philosophy in the construction project, and the barriers to adopt this concept in order to benefit or to maximize the benefits of both of them together. Also, there's a need to study their applicability during the different phases of the project life cycle. There's a need to create new business models in order to identify the possibilities of these applications. And in addition, to create results-based or impact-based application of lean construction 4.0 to integrate sustainability, design for deconstruction, circularity, and value for the earth. So thank you for your attention. I hope that I was on time.
Yes.
Here are
perfect.
my contact
Thank
details.
you, Wassim. Thank you very much.
My pleasure.
Yes, on time, and this was a great presentation. We will immediately jump into the next presentation. Dorra is here with us. Dorra, hi.
Hello,
welcome.
hi,
I think
Henry.
you are from the same institution, right?
Yes, but when I finished my PhD, I moved to a new company. Kadrij is a company for a high-end renovation project. So
Okay, it's a pleasure having you here today. We are
Thank
ready
you.
for your presentation.
Thank you so much, Henry, for having me. I will share my screen.
Sure.
Can you see it? No?
Yes, we can.
Just one. You can see the slides?
Yes.
Okay.
We are seeing presenter view. Is that okay with you?
No.
We can see all the notes.
I will take it off. So
this is perfect. Now we are seeing the presentation. Yes.
Okay. So today I will present a part of my PhD work is lean and digital twin in brick manufacturing. So I will start with the introduction for the bricks manufacturing, introduce lean and industry 4.0, the methodology and the conclusion and first steps. So as you know, the bricks are one of the oldest building material and present nowadays, they are used in more than 25% of houses and construction projects. So some of challenges that bricks manufacturing is facing is the increased population growth, the migration to urban areas, unreliable supply chain due to the impact of COVID, and others like wars and disaster, like the war, especially the war in Ukraine, which create a gap between demand and supply of housing. Other challenges that the bricks manufacturing are facing is the environmental impact due to the high consumption energy due to the kiln for the curing part of the process, and also this skilled labor, and productivity and efficiency, and the low quality and operational waste. So to overcome these challenges, we used the Industry 4.0 to reduce waste, to improve the operational excellence, and to improve the energy consumption. Some of challenges that we face during this project is the lack of knowledge and skills in SMEs, especially with the Industry 4.0 and with new technologies. So the case study is a company based on the north of France, which is a family-based company with more than 100 years old and produce different type of clay-based brick, and it's a provider of brick for many projects in France, England, Ireland, and many other locations. So the process that we studied, it starts with extraction and storage of raw material, preparation of the mixture with burying, grinding, and transfer to the aerial feeder, and then with shaping with the extrusion and cutting the pudding, and then we go to drying to reduce the humidity of bricks to between 100 and 4 from between 1 and 4%. And then we go to curing in temperature which can attain 1,100 degrees Celsius. And then we go to the quality control, palletization, and finally to the storage. So we started with making, we studied the current production process with to collect data and make some interviews with workers. There is also some data collected with sensors that already exist in the SME. Then we made some observation. We stayed around 3 months or more to study the process and take to measure some data, so we can make our VSM, the value stream mapping, as a static model, and then we will make our virtual model with digital twin, and to put all the data that we collect for the VSM, then we can create the future production and create the bidirectional data flow between the physical and virtual model. So the idea was to implement predictive maintenance to predict future failures in machine and avoid machines breakdown that would cause productivity loss, because it's a problem that is which is happen very often in the company. So the use of an interactive model that links the physical process and the digitalization process to provide real-time data and update about the effectiveness of change in the process, the production process, especially that the SME is trying to implement the multiple principle of Industry 4.0. So this is the VSM that we get at the end. We have the different phase of the process. And we have the cycle time, the different data that we collect, the cycle time, change over time, the weight of material, the flow, the energy, type of energy, the power of the machine, the energy consumption especially, and the temperature and the time of working per year. So with making the VSM, we get as a result that there is a high level of defects in different places along the process, stoppages in the production line due to some reasons such as fallen bricks in the wagon path, problems in machine, and stoppages due to the cutting machine. The latter is responsible for a lot of stoppages, around 5 to 6 times per day, due to frequent failure in the cutting wires, which require their replacement each time. And each time the machine stop, it requires around 15 minutes to put the new wires. Also, there is a level work in progress which affect the freedom of movement and create problem in brick storage. So the idea was to make the digital twin of the production line, which was made in collaboration with Dassault Systèmes and Central Lille. So we create the 3D modeling of different state of brick. We start with raw material storage, mixing, grinding, the column to be cutted, and then we have dried brick, fired brick, and package. And then we create the manufacturing of bill material, which integrate the different 3D model of brick in the logical order of the manufacturing process. Then we make the process planning and flow simulation, which cover creating workstation consistently with the flow in the original process and linking them due to the previous phase. So in each phase, we create the workstation, and we put this parameter for each station: the flow, the cycle time, the estimated operation time, interval between failures, repair type. So this is the same data that we collect in the value stream mapping. And each workstation has to be connected to the workstation after and the one before. At the end, we get this production line with different steps, and for each step, we have the different workstation. For example, we have for the cutting machine here, we have the conveyor belt, we have the cutting machine, and another conveyor belt that sends the material to the storage and then to put it to send it to the dryer. As a result, the digital twin presents useful information in the shape of a Gantt chart about the system, the operations, duration of each part for each part of the production line, and the most important part is the rate utilization of the system machine. So, for example, here, which in green, it means that there is a low utilization rate of the machine. So it's something bad. I don't know why it's in green, but it's the software. So here, for example, if we want to make any change on the machine, we can test different scenario and try to test how it will impact all the process production line. So which will enable us, if we can stop the production line, to change some parameters of the kiln, for example, or we cannot do it. So I will present a kind of a scenario that we test. As I mentioned before, there is the cutting machine where the wires are frequently broken. So each time the wire broke, we have no sensors. So the workers, it will detect that there is a problem in the wire machine in the next station. So here the idea was to put the sensor to test, can predict the breakage of the wire and automatically will stop the process. And once the process is stopped, there will be a kind of sensor to inform workers that the line is stopped. So here the rate utilization of the machine, and we suppose that there is 6 stoppages per day, and for each stoppage it's 15 minutes to change the wires. So this problem will reduce the rate utilization of the machine per 7.5% of use the machine. And the second scenario that we tested here, so facing bricks are produced by sewing conventional bricks, which create a lot of waste of material, of energy, and even time for workers. So manufacturing them directly to the right dimension by modifying the production line would save over 6% of the energy used in the brick works annual production. So the idea was to test if we can make some change in the production line, and we produce our facing bricks and then go back to produce conventional bricks. So to make these changes, we need 35 minutes change. So it will reduce more the utilization rate of machines per 2.5%. So with the stoppages of the wires, the broken wires. So here it will affect the utilization of the machines per 10%, which cannot be possible. So the idea is to make a second production line for facing bricks. So the future step, a network of sensors is currently under construction to be connected with the developed virtual model to ensure the bidirectional flow of data between the virtual model and physical model, because the idea that the sensors are very expensive. So we are trying to how we say it, to ask for funding from the government, because it helps SMEs to develop and to change the production line to Industry 4.0. And making a network of sensors will help us to integrate more detail in our digital twin, so it can help us to analyze more the production line. So as a result, the proposed framework allows to a dynamic and continuous monitoring of the production line and testing different production scenario and integrating real-time data to improve predictability. The contribution of this work it shows an example of Lean and Industry 4.0 integration to digitalize in SMEs and to improve performance in brick manufacturing. And as a future research, we try to modify and test the framework in other industry, so we can define the KPI, and also we want to investigate the impact of the model on the performance and identify key performance indicator of the framework. Thank you so much.
Thank you so much, Dorra. Everybody's on time in this session. This is wonderful. Thank you. This was a great presentation.
Thank you.
I tried to understand everything, but it was difficult because of the concept. But yeah, you explained everything very clearly. Thank you. Thank you.
Thank you so
for
much.
being here. Okay, we have the last but the least presenter here, Slim Rebai. And Rebai, the floor is yours. We are excited to hear your presentation.
Thank you so much. So I'm sharing my screen. Are you seeing my screen?
Yes, perfect.
Okay, so thank you for inviting me. My name is Slim Rebai. I'm in my final year of PhD studies, and I'm working on the advanced work packaging methodologies for complex construction projects in partnership between Central Lille here in France and Concord Project Technologies. So our main presentation will be about 5 main questions. What is AW methodologies? How does AWP work? How can we integrate AWP, and how to integrate the AWP in the industry, and what are the impact of in the organization? So the first question was, what is AWP? Advanced Work Packaging is a new methodology for managing complex construction projects to improve their performance. And it is a construction-driven project delivery process that adopts the following principle that the customer is the construction on itself. The meaning of complex projects here are divided in three main sectors, and we are making research about that. We can say that where there are simultaneous interactions and there are several stakeholders, and the project can be on a duration for several years. So the historical background of the AWP, it's in its origin, it's what created initially in the North America between Canada and the USA. And it was a consortium of 13 organizations. The University of Texas at Austin is one of them. And it was under the supervision of the Construction Industry Institute and the Construction Owners Association of Alberta between 2011 and 2013. And at the end of this consortium research, the advanced work packaging methodology was denominated as best practices for construction projects. So this methodology was integrated in several construction projects, mainly in energy sector, in petrochemical industry, in mining, in infrastructure, in industrial aspects. And it gave so many performances. One of them is the safety. The organizations that implemented AWP have recorded 0 accidents in some cases, and it implement a total decrease of production costs by 10% and increasing productivity until 25% of labor productivity. We can say that these performances can be reachable at a stage of maturity and of implementing the AWP in the organization. So how does the AWP work? So the AWP principle is it is a construction-driven planning methodology, and its value is in improving delivery and execution efficiency. And it is dedicated to complex construction projects, and its main principle is about full sequencing of all the work packages that are planned without constraints, starting within the mind to do the work in the right way from the first time. So the AWP stakeholders approach, its main idea is to invite and involve all the stakeholders from the beginning of the project, and they are will be working together to develop interactive planning. And as it is an execution-driven process to resolve individual constraints, and all this path is managed by the construction team project. So the main deliverable of this methodology is the path of construction. And here it is concerning of logical sequencing of the construction work. We can see here in the right image that the plot plan was divided in several areas, and we can see that here the arrows marking the construction path of the project. So the quality of the construction plan is explain the know-how and the experience of the poor quality and it is an indicator for the likelihood of a project success. And the second main deliverable of the AWP is the construction work areas. And here in our project, we decompose the plan into different parts of the site plan represented logical work areas. And here the construction work areas will include all the disciplines, and in the image on the right, we can see a selected construction work area. And this construction work area will be divided in itself in several construction work packages that are logical, manageable distribution within the scope of the construction, and they are divided in a single disciplines. And here we can see the example of dividing the pipe work in the construction project. After that, we need the input for the construction work packages, and here we are talking about the engineering work packages and the procurement work packages that are the deliverables for maintaining and doing the work of the construction work package. And after that, as this methodology is construction driven, we have every construction work package will be divided in installation work package, and these deliverables are enables an installation team to carry out safely, predictably, measurably, and efficiently the work that they have to do. And here we can see the overall sequencing of the work package. We start with decomposing of areas, and in each area we will be focusing on disciplines, and in each discipline we will need the engineering and the procurement work packages, and to finish with the installation work package. Once we how to integrate this methodology, the question is, can we really integrate the AWP? Here I'm sharing with you the implementation of the AWP worldwide. And here we have more than 40 regions in the world that implemented the AWP in their projects. One different cases that I'm sharing with you, we have international airport modernization in Canada, the power plant construction projects in South Africa. We have the power plant construction project, the Baraka in the United Arab Emirates, and the copper mine construction project in Mongolia, and the refinery construction project in Canada. So there are several companies that are interested in AWP. I'm sharing with you a list that is not exhaustive, that were interested in AWP. And one of these companies are Shell, Worley, ExxonMobil, Samsung Engineering, that these companies implemented AWP in their projects. And also there are other types of companies that are offering the AWP as part of their software solutions, like Autodesk, O3 Solutions, and other companies. So the AWP could be identified as a solution for all critical planning elements, and it is a detailed engineering that solves all the constraints. And finally, once on the site, on the construction phase, the methodology changes to be an agile approach. And here we maintain that we have no mobilization on the site until we solve all the constraints that have to be solved yet. So the traditional approach of construction projects is a linear construction methodology or project approach, and the AWP is based on collaboration between the project owner and the project manager in the first way, and after that, in the collaboration between all the team of the project members. So the first question is how to integrate the AWP. The first of the need is to maintain a good preparations that involve all the engineering to respect dedicated times. And these preparations have to integrate a stronger sequencing of activities on the project. And this preparation have to be construction-oriented planning as a result. The second need is the contracts on themselves. The contracts that will be used in on the project have to integrate the AWP expectations at the outset of the projects. And here the stakeholders' coordination and involvement have to be right from the design phase. And Also, we have to integrate the training, the support, and the coaching of the AWP. And here I'm sharing different ideas and training courses and materials that could be integrated with the AWP. As I'm working in a partnership between Concord and Central Lille, we are trying to implement the AWP in the French construction market here in France. It is to mention here that the AWP is translated in English, in French, and in Spanish language. And we are proposing trainings for companies and for researchers at the same time. So here are the different types of training that could be provided for the AWP methodology. We can see the different languages and outcomes of training AWP. And here I'm sharing with you example of certification that are provided when making the AWP certifications with its different roles. So this leads us to our final questions. What is the impact on the organization when implementing AWP? To be honest with you, I can say that the only new role in the organization is the AWP champion. That is a new role. It is not the project manager. It is a specific role that is dedicated to implement the AWP on the organization. And here I'm sharing with you the impact on the organization when implementing the AWP. And here the yellow boxes are the changes on the organization when implementing AWP. And here the red boxes are the changes that our subcontractors have to integrate to follow the process of implementing the AWP. It is also to mention that the integration cost for AWP varies between 0.5 to 3% of the total cost of the project. And here I'm finishing my presentation, and thank you for your attention.
Thank you, Slim. Okay, all the presentations are completed, and we can now take questions. Any questions from anybody? It's very interesting subjects, and thank you all for being here. And anyone? There is one question, but I am not able to read it. It's in a different language, so
it's about a certificate for those who are attending certificate. I think it's for the organizers.
Oh, okay. Okay. So it's something else. It's not a question about the presentations. Okay. I wasn't sure.
Yeah.
Thank you for translating. Since
pleasure.
you talked to Wassim, you'll get the question from me. Okay. So you talked about lean construction and 3D printing. Very interesting subject. And you talk about applicability during the main phases of the project life cycle.
Yeah.
Towards the end, you mentioned that as a future direction.
Yeah.
Or maybe a barrier.
Yeah.
Could you please elaborate on that a little bit? Explain like how that could be a problem or how it could be implemented.
Yeah, in fact, it's not a problem. It's a direction to be investigated. So the idea of lean construction itself is about improving the production system. So lean in general, it's a philosophy to improve the production system in general. It's about improving the processes and creating a continuous improvement culture. So therefore, the focus on the implementation of lean construction received greater attention in the construction phase in comparison to the other phases, because it's directly related to the production process. A little attention or less attention was received to the design phase. There are many concepts about lean design, but maybe the integration of the whole project life cycle for lean construction and for construction 4.0 would be an interesting idea to be covered. And in the presentation, I mentioned relating that with different topics, including, for example, design for deconstruction and circularity. So it's linking everything. So it's not working on only, let's say, specific period of the project, but also trying to integrate the overall project life cycle with these concepts.
Thank you, Wassim, for explaining it further. Thank you. Anyone else has any questions for Wassim or anybody else? Otherwise, I have one more question. No? Okay.
Yeah.
Dorra, the question is coming to you. So again, towards the end, you mentioned we can modify and test the framework that you presented in other industries. That's what you mentioned. Which industry would be a good match, you think, to implement this this framework? And like, what would be the first one you could think of, or can you give some examples to that?
So the work was made especially for SMEs, because here for I don't know in other countries, but especially in France, SMEs, they think they are not capable to start working to implement Industry 4.0 principle. So the idea is to show them that there is possibility to implement for Industry 4.0 principle with collaboration, for example, with academia. We started just by interviews, collecting data. You can do it manually if you don't have, you can't afford to buy sensors and to implement to make a network system with the sensors. So the idea is mainly SMEs and industries. It doesn't matter the type of industry, it's just for SMEs. And I'm trying to do now the same thing with company with construction, is to start with study the main process, the current process in the company, and to define, you can do it with VSM, you can do it with only tables to collect data to see what is wrong in the company, what the bottleneck of the process. And then we can think about the technologies and how tools, we have a lot of tools today, we can implement whatever we want, but it's more, the most critical phase, I think, is to detect what are the bottleneck of our process, what doesn't work in our process. So then the tools, we have a choice to implement whatever we want. So I don't know, bricks manufacturing, maybe we can do it in also a glass manufacturing, because it's almost the same thing, because there is a high energy consumption in the glass manufacturing also. We can start with that to respond to your question.
Thank you. Glass. That's very good. Okay, very good answer. Thank you both. And any questions? No? Okay, my last question. Slim, it's coming to you. So we have 4 more minutes. Take your time, 4 minutes. But advanced work packaging you talked about, and could you please tell us what is the next first step moving forward?
Okay.
I know this is a very general question, but that's what I'm curious about. if you could answer.
So I will talk about the objectives of my PhD research in this partnership between Concord and Centrale here in France, because the idea is this methodology is start to be implemented in different regions in the world. So the idea is why not to implement it here in France? So, and with that, I start working on that, the AWP for the construction industry in mega projects, petrochemicals and all that. And the first question is this methodology really applicable in different construction sectors like building, classical construction projects or not? And this is one of the challenges that we are working on. And the second step is, could we really implement it here in France? Is there any barriers to implement it, regulations, mindset? So we are working on that, on these aspects. And also, as Wassim said, so we are working AWP, lean construction. Lean is earlier on construction projects. So one of the main the different questions that always I'm asked is what is the difference between the AWP and lean construction? Is there any similarities or differences between these approaches or methodologies? And we were also working on making or highlighting the similarities and the differences between these two methodologies. And each one of them has its main properties and characteristics. So the idea after all that is try to implement the AWP in the construction France sector in the first time, and then move forward to the all European region.
Yeah, Slim. We are right on time, and I want to thank you all. I think we had a great session. Thank you for attending. Very impressive work, each one of you. Thanks again for being here.
Thank you.
I see Professor Anderson is here. Hello, Professor Anderson. How are you? Good seeing you. You're muted. You're muted.
Sorry.
Hey,
okay.
How are you doing?
Yes, I'm
Everything
here.
is good. It's good to see you.
It's good to see you.
Oh my goodness. Yeah, this is a great opportunity. Thank you again for having me. And floor is yours, microphone is yours. And yeah, I'll be here. I'll try to attend as many sessions as I can. Thank you again, Dr. Hanadi, for having me. And thank you, everyone.
Thank you. Thank you.
Okay. Bye-bye.
Thank you, Professor.